So here's an idea that shows up in math a lot of times. You can take a math problem and solve it in two different ways and come up with the same answer. Let's try it here. So one is you can do trig substitution. So you can draw a right triangle and say this is the angle theta. And because these two are being added together, if you do the Pythagorean theorem, it's actually these two sides that get added together. So this side could be an x and this side could be a 2. And that way when you do the Pythagorean theorem, this is going to be x squared plus 2 squared. So that will be x squared plus 4. And then if you take the square root of that, that will tell you the hypotenuse. So the square root of 4 plus x squared, or x plus 4, is the hypotenuse. Now we need to do a couple of things. I do need to find out what dx equals. So the first thing to do is find out what x equals. So if I divide these two sides, I'll be able to see what x equals. I could divide these two sides, but because both of these have an x, it would be very difficult to solve for x. So I'm going to use these two sides. And that is going to be tangent. So tangent of theta equals x over 2. And then I can very quickly solve for x. So 2 times tangent is equal to x. And now take the derivative. So on the right side, it's just going to say dx. The derivative of tangent is secant squared. So this will be 2 secant squared theta times d theta. All right, so the dx is going to get replaced with this. I also need to see what's going to replace this fraction. So if I were to use this side and this side, I could at least get that 4 plus x squared into the problem. I'll probably have to square to get rid of the radical, but that's a start. So if I take the adjacent over the hypotenuse, that is going to be cosine. So cosine of theta is equal to adjacent over hypotenuse. And it's supposed to have a 1 on top, and it's not supposed to have a square root. So the first thing I'll do is square both sides. So cosine squared, and then square this side. So that's going to be 4 over the 4 plus x squared. And this only has a 1 on top, so I do need to get rid of this 4. So multiply both sides by 1/4. Okay, so now we know what the fraction equals. So this fraction, so this part is going to get replaced with the 1/4 cosine squared theta. And then for the dx, we're going to replace it with 2 secant squared d theta. So it's going to look like integrate a 1/4, and then the fraction gets replaced with cosine squared theta. And then there's the dx, and the dx gets replaced with 2 times secant squared times d theta. And before integrating this, we could actually reduce. So secant is 1 over cosine. So that means that this one is 1 over cosine squared. And if you have 1 over cosine squared, it's actually going to cancel the cosine squared. So believe it or not, all of this trigonometry gets eliminated. So all we have to do is integrate. This is a 2 over 4, aka a 1/2. So that's all we have to integrate. So the antiderivative will be 1/2 theta plus c. And then we need to see what theta equals. So if you go back to this one right here, you could just take tangent inverse of both sides. And so it's going to be tangent inverse of the x over 2. So my final answer is going to be 1/2, and in place of theta, you can put tangent inverse of x over 2 plus a c. Okay, and then I did say do it two ways. So start over, and I'll just start with the fresh piece of paper because that one's sort of full. Integrate a 1 over 4 plus x squared dx. And for that one, on my little 3x5 card, I know that if it's integrating 1 over 1 plus x squared, then the antiderivative is tangent inverse. So the second way I'm going to do it is I'm going to try and make this look like this and go straight to the answer tangent inverse. So this should be a faster way. So this needs to be a 1. So that means I need to factor out a 4. So factor out a 4. So when you factor out a 4, that's the same as dividing, because right now this is saying multiply. So the opposite would be I divide by a 4, which means this is a 1. And then if I divide this one by 4, I also need to divide this one by 4. And of course, you could always check and see if I did it right. If you multiply, yep, that's a 4. And if you multiply, yep, that's an x squared. Now the next thing to do is, if you look at this part, this says whatever this is, it has to be a squared. And whatever that is, it's going to end up right there in the answer. So this can't say x squared over 4. It has to say something got squared. So for this part right here, I could rewrite that as x over 2 got squared. So 1 plus, and then an x over 2 got squared. All right, then I could factor out this 1/4. And we're almost there. So if you compare what I have to this, it's very similar, except instead of an x right here, I've got x over 2. So I would have x over 2 right here. There is one small detail, and that is if you do u substitution on this, which I'll go ahead and do. So let the u be what's inside the parentheses, and you take the derivative of that. You would get this extra factor of 1/2, and there is no 1/2 times dx. So I need to eliminate this, multiply both sides by 2, and then that is what the dx equals. So basically it's saying that yes, this is going to be tangent inverse of x over 2, but you do have an extra 2 that you need to consider. So there would be 2 times du. So then this would become the 1/4 is still factored out. And then in place of dx, we're going to put 2 times du. And this 2, I could just factor it out. And then the rest of it would look like 1 over 1 plus u squared, because this is being replaced with u. And then this reduces to be a 1/2. And then this is going to be tangent inverse of u. And usually I would write the tangent inverse of u and then replace the u, but you can do that in one step. So this is tangent inverse of u, but u equals x over 2. And now for the final check. The last time I did it with the trig substitution, are the two answers the same? Yes.